Hey guys, welcome to the fourth part of this tutorial series, making a simple HTTP server in Java. On the last part, we made our server deliver an hard-coded page to a browser. Now we're making the server accept more than just one connection, and for that we'll be using threads. So the first thing that we are going to be correcting is having the server socket on the main method. This is really horrible, yeah? We are running the server socket on the main thread, and when we get to the accept method, the execution just halts. It just stays there until we accept the connection. Yeah. After we accept the connection, we get the streams and we do all that processing. But basically, it just gets stuck in here. If we never get a connection, we never finish the execution of this method. And we might want to do more things on the main thread. Yeah. To correct for this, we'll start by putting all this section inside a thread that we're going to call server listener thread. So let's create a package over here called core. And inside this core package, we are going to create a class, which is the server listener thread, just like so. Because this is going to be a thread, yeah, we need to extend this from thread. Okay. We could have implemented runnable, but I prefer for this particular case to extend from thread. And let's override the run method. So override methods, run. We'll just leave it empty for now. Let's look at the main method again. So as you can see, we are getting our port and web root configuration from the configuration manager. And in our particular case, our server only listens to one port and only has one web root. But if we later want to make the server more functional and have it allowed to serve like on multiple ports and handle different web routes for different domains, we can do this very easily if we start making our code ready for such possibility right at this moment. So with that in mind, we are going to have the server listener thread have a constructor that takes in the port and the web route. Now remember, we could have the configuration manager inside the server listener thread and get those values from here, but because we might want to make the server better in the future, we'll pass these values through the constructor. So let's do this. Private int port and private string web route. And let's create the constructor. So now let's start by moving the server socket into the thread. We get this and we place it over here in the constructor. Like so. Like this. And because we are creating a server socket and the creation might fail for some reasons, like for example the port is already in use, or if you don't have permission to use that port, it can generate an IO exception, which we are going to declare the constructor can throw, like so. Now we have the remainder of the code that deals with accepting the connections on the server socket. So let's move all of this into the run method of the thread. So I'm going to copy the try, like so. Move it over here. Perfect. So this thread is now doing everything that the main method was doing before on the main thread. Okay. So let's now create the thread object over here. I'm just going to delete all of this and I'm going to create a server listener thread like so. I'm going to create it and give the port to it and give the web route to it as well. Yeah. And I'm going to start the thread straight away. Okay, you can see that this is signaling that we can throw an IO exception. So I'm going to surround all of this with a try-catch block, like so. And we'll just leave it like this for the time being. Later. So let's give it a run and test it out. Perfect. It's working exactly like before, but on a different thread. So before we go any further, let's take care of the logging bits of the app. We have been using system out print line to print all of these debuggings and info, so we see the application running. So let's start using a proper logger. So we'll start by including the simple log facade for Java in our POM. So the group ID for it is org.simplelogfacade for Java, like so. And we are going to include simple jog facade API, and the version is going to be 1.7.29, which is the current version at the time I'm doing this tutorial. Yeah. Now we're going to say that the simple log facade for Java is going to use logback, the logging system. So we're going to include that one as well. We just add version straight away. And the group ID is ch.qos.logback. Like this. And the artifact is going to be the logback classic. And the version is going to be 1.2.3, like this. Now there's no particular reason why we're using logback, because in fact we're going to be using the simple logging facade for Java, and later we can change the logging system without modifying any code. So let's modify our HTTP server so that we start using this logger. Private final static logger. And correct equals logger factory dot get logger, and we're going to say HTTP server dot class. So we get the logger for this class. And now we are going to replace everything that's got system out with the logger. Let's delete that, copy this. In fact, done. Let's do the same inside the server listener thread. Let's remove this and use server listener thread. Let's remove this import. I'm going to clean it up as well because we had these imports over here that we're not using anymore. And let's now add some logging here. .info, just so that we can see when a connection is accepted. And we are going to print out the get init address of the client. So perfect. Okay, so now that we have this logging bit out of the way, let's look at how we can make our server accept more than one connection. Because as you can see, after this first request, we try another one and it fails because the server just finished with an exit code of 0, which is actually good. It all went well. But we don't want that. We want to be able to have many browsers connect to our server. And we do that with a while loop. So while true, create this, and we'll leave this one out. The server socket close out. I'm going to comment this and leave here a note for me to handle this later. We don't want to close it because we want to keep on accepting connections. And before we give it a run, let's not have this loop run forever, but let's instead run while the server socket is in a good condition. So server socket is bound and the server socket is not closed, like so. So while the server socket is good, we keep on accepting connections. Let's give it a try now. So call this as well. So we can now accept many connections, but there is a problem. The way that it was built, it will only accept one connection at a time, yeah? What happens is the server socket, this one, has got a queue, and we get many browsers to connect to the server socket, and their connections get placed in the queue. And each of those connections is processed one at a time in series. One problem is, if one of the requests would take too long, the other ones would be on the queue just getting delayed on the processing. Let me demonstrate this for you. So after we close, let's say sleep for 5 seconds. Okay, I'm going to surround this with try catch. It's just for testing, so I'll just leave it like this. And let's give it a run again. Stop and rerun. And let's test this out. Let's go. So as you can see, all these requests are being delayed, and they are finishing as we go. As you can see here, also on the log, we only accept one at a time. And then because each of our acceptance is going to take a 5-second delay, because we just made it so. So as you can see, it's not very performant, is it? Let's just stop this. So what we need to do is, again, use threads to perform all the requests independently of each other. So we'll just leave the server listener thread in charge of accepting connections, yeah? But the actual processing will be done in a different thread. So let's do as we did before for the server listener thread and create an HTTP connection worker thread. Inside core, so HTTP connection worker thread, like so. And just like before, we extend from thread. And again, like before, we override the run method. Perfect. So what is the HTTP connection worker thread going to be doing? Let's look at the server listener thread. So the server listener thread is going to accept the connection. We get a particular socket. At this point, we straight away pass it to the HTTP connection worker thread, and we fire it up. And we'll let it do all the communication and handling of messages there and all that stuff. And in here, we continue accepting more connections and creating further HTTP connection worker threads and firing them up. So let's do this. Let's grab all of this, including the sleep, actually. Bang. Let's move it into the HTTP connection worker thread, into the main method. Bang. We'll just place it over here. Good. So we're missing the socket, yeah? And we know that we want to pass it into the constructor. So like this, socket, socket. And we are going to define it outside here, private, and say that this socket equals socket, like so. Now over here we have I/O operations, which are going to throw I/O exceptions in some cases. So we are going to surround all of this with a try catch. And we'll handle this later. Handle later. Okay. And we'll leave the sleep here for the time being. And let's create some logging. So we don't have a logger. Let's just copy this over here. So thread logger.info processing finished, like so. And now let's create the HTTP connection worker thread over here. we pass the socket in like this, and we start the thread. It's looking good. Let's give it a try. Now everything is getting processed really fast, even though we only finished the work of the thread after the sleep. So the connection processing finished only shows up quite a bit later, but we are processing it all at the same time. As you can see, even here in our logs, we can see the threads that are being executed and finishing. Let's remove the sleep. And it's looking good. Let's see if there's some more cleaning up to do. Let's just close the POM. Nope. Looks good. Now to finish everything off, we got to make sure that the server socket, when we finish this loop, actually closes. So I'm going to create a finally here. I'm going to say if server socket is different from null, which it should be. But anyways, let's just make sure we say server socket.close. And this is where we're going to close it. So let's remove this. And because it can throw an IO, we're just going to surround it with try catch, and we actually going to catch it but not do anything. We'll just disregard and close it. So that's good. And we'll do the same thing for the HTTP worker thread. All these closes we are going to close on the finally clause, like so. You're going to bring all of this into here, and obviously we need to define this outside of this try so that the finally can have a scope that they both share. It's going to define them as null. Set this one as null as well, like this. And now we are going to do the checks. So input stream different from null. We execute the close, but we surround this with try catch. And we are going to do one for each. Different from null. And surround with try catch and do nothing with the exception. And if socket different from null, surround with try catch. Let's do nothing. So it's looking good. Here we are going to do some logging, some proper logging. So logger dot, let's say it's an error because something went wrong. Problem with communication. And we pass the exception over to the logger so that it prints out the information that we need to see over here. And there was some IO here that we needed. Yeah, let's do the logger here as well. And it's problem with setting socket, like this. This will help us if we see any problems, identify where it happened just by the message. Obviously, we're going to have the stack exception. So we can actually look at the stack dump and see where it happened, but just having this be literal is just going to help us out. So let's give it another try. And it's super fast now. Perfect. And that's about it for part 4. In part 5, we'll be looking at proper HTTP protocol and the RFCs that make part of it and that you should look at, and start handling the protocol properly instead of delivering some hard-coded page all the time. I hope you enjoy this tutorial, and don't forget to like and subscribe and all those things that you know. And I'll see you in the next tutorial. Bye.